So, hey everyone, I guess all of you are busy preparing for the finals. There was this question about describing functions. The way I've solved it in homework 7, I believe, with all the math. And I just want to give you a particular perspective as to how you can solve it by just using the equations on page 612 and 613 in the textbook. So just giving you an example here, you don't have to, so that you just understand how describing functions work. In this case, is you're given this circuit where you have this high gain amplifier. It's a negative feedback. You have this tank attached here. You're asked what's the final, and tank amplitude or tank voltage of oscillation here. So just looking at the circuit, you can, and you know that this V out is limited between plus Vm and minus Vm. Now what you saw was that let's see, yeah. Now because now this V tank, if it starts swinging like this, and that's its amplitude. So think about what happens around 0 volts. So around 0 volts, as this voltage V tank tries to go up, because of this feedback system, V2 follows V tank. So as V tank goes up, V2 goes up. And because V2 tends to be equal to V tank, this point tends to be equal to V tank. Then because of this voltage division, V out tends to be twice of V tank. So when V tank is near the 0 voltage, you get a slope of 2 in the transfer characteristic of V out versus V tank. But as soon as V tank reaches Vm by 2, this is Vm by 2, so this is Vm by 2, so this is plus Vm. It cannot go beyond that, so it rails. So you have this thing here, right? And similarly on minus Vm by 2. So what you have here is that if I have a V tank like this, my V out is going to look like that. So now can I use describing function analysis and say that if my V tank is a particular voltage, a sinusoidal voltage of amplitude, VA, what is the describing function V out at this point for that amplitude? Because if I know what that V out is, I can find out what the net negative resistance looking in here is. And if that negative resistance is equal in magnitude to this RT, I will get an oscillation. So I'll have to then solve for VA. So how do you go about this? So from here you get this. Now if you get this, you can go to the textbook and go to equation, or this figure 17.12, which is what I've repeated here. And on 612, there's this describing function for that that has been described here, that if there is a V in voltage and a V out voltage like this, and if it has a slope of K, so at an input of EM it rails to KEM, and an input of minus KEM it rails to input of minus EM it rails to minus KEM. In that case, the describing function, what the describing function GDE means is that if E, I should write this as E, if E is the amplitude of the, if E is the amplitude of the sinusoid, can you, if E is the amplitude of the sinusoid at this, here, if it's oscillating like that, what's the sinusoidal V out amplitude that I get? So if E is less than EM, I get K, because if it's here, I get K times E. So if this is GDE, I can write V out as a function of E to be equal to, okay, so I can write V out as a function of E to be equal to K times K times E, and here I can write it to be 2K by pi sine inverse of R by plus R by 1 minus R squared times E, where R is equal to EM by E. So these equations are for this case. So if you map this to that, what I can do is I can then write that I can write my R to be Vm by 2, because my Em, you see my Em is plus Vm by 2, and my E is Va, because that's the amplitude of the V tank sinusoid, right? So that's equal to Vm by 2 Va, and then I can write that my V out is equal to and of course my K is equal to 2, because here k is the slope. I find that the slope is equal to 2 here. So I can write k equal to 2, V out is equal to 2 times VA, because E is VA, or 2 times, or actually 4 by pi times sine inverse of Vm by 2Va plus Vm by 2Va root of 1 minus Vm by 2Va squared times Va, right? So that's my V out at a frequency of omega. That's what the describing function says. So if I go back to this circuit, let me just copy this circuit over, right? So what this says is, if I have an amplitude of VA here, the amplitude of the sinusoid, because of the describing function at V out, is going to be this, right? This. But so let's assume that it's this. So in that case, what's the resistance hanging in down there? That resistance is basically that voltage V tank, right? V tank divided by, so which is equal to VA. So that's VA divided by the current that goes in there. So what's the current that goes in there? That current is V tank minus V out by RF, right? So that is equal to RF times, and V tank is equal to VA, so it's VA by VA minus V out. Now of course this number has to be negative, because that's the negative resistance, and that basically means that VA is smaller than V out. That number has to be negative, and that negative number's magnitude should equal to RT. So what I can then write is RT is equal to minus of RF VA by VA minus V out, because that is what is going to give me an oscillation. So that basically means that I can write RF by RT, RF by RT is equal to V out minus VA by VA. So that basically means 1 plus RF by RT is equal to V out by VA. So what is V out by VA? That you can go back here. So my V out is equal to this whole thing times VA. So V out by VA is nothing but 4 by pi sine inverse of Vm by 2Va plus Vm by 2Va root of 1 minus Vm by 2Va squared, right? So this is that. So that's equal to 1 plus RF by RT. So you know what Vm is, you know what RF is, RT is, 4 by pi, everything is known. So you just have to solve this equation implicitly to find the VA, and that you will find out to be 0.7877 volts. So this is quite similar to what what I derived in the homework solutions. So if you look at the homework solutions, all the math, this is what was derived. So you see this thing, right? That's what I derived with the whole math. You get that directly here by using the the describing function analysis. Now in the final exam, if you get a question on describing function analysis, now you're not supposed to, you'll not be asked to implicitly solve this equation, and you might be pressed for, oh, what if I don't have a a scientific calculator? So don't worry about that. This video is just to help you a bit in understanding how describing functions work. So again, all the very best with your work, with your finals. Sorry.